Welcome to Calculus. This is lesson number 1. I'm following a book by Larson. The very first chapter in the book is not called chapter 1, but it's called Preparation for Calculus. And this is the first section in Preparation for Calculus, P.1, Graphs and Models. All right, so it wants us to review how to sketch a graph by plotting points. I would do it by just doing a translation. It's the square root of x. Let's recall that when it's added inside the function like this, it makes a shift. It makes a shift to the left 2. So it takes the original parent function of the square root of x and it shifts it left 2. So it's going to start at -2, and then at 0, it's the square root of 2. And then at, let's put a 2 in there. If we put a 2 in there, it makes 4, and the square root of that's 2. So that's a sketch of it by hand. You can double check it on a calculator, but it did tell us to sketch it by hand. So you are supposed to be able to do some things for the Calc A, B, B, C test by hand, so you should practice doing that. All right, so it was the square root, so second square root of x plus 2. Ooh, I got to clean that up there. So my zoom is kind of out of whack, so I'm going to go to zoom and choose number 6 standard, and there it is. Okay, the next one. It's the rational function 1 over x, which you recall looks like this. It's got a horizontal, let's see, y equals to 0, it's got a horizontal asymptote, and at x equal to 0, it has a vertical asymptote. And because of the plus 2 that's down here, that means it's going to shift it to the left 2. And so the vertical asymptote, instead of going through 0, is going to go through -2. And it's got a horizontal asymptote of 0 again. So x equal to 0. So how do I know it has a horizontal asymptote? Because looking at the highest powers of x on the top and the bottom, we have 1 over x. So as the graph goes to infinity, it becomes 1 over infinity. So that's pretty much the number 0. So the bigger the numbers get, it goes to 0. And again, the vertical asymptotes are where the denominators equal to 0. So setting the denominator equal to 0, x plus 2 equals 0, would make x equal -2. So that's why it has a vertical asymptote there. And so it gets closer and closer to both of those, but it never touches it. So putting it in the calculator there and checking it, 1 divided by the quantity x plus 2. There you go. So it's the picture that we just had. So they just said to sketch it. So that's good enough for now. Okay, down here it says approximate solutions using technology. In 17 and 18, use a graphing utility to graph the equation, move the cursor along the curve to approximate the unknown coordinate of each solution point, accurate to 2 decimal places. All right, so putting it in our calculator, they said as we could, we got x to the 5th, so x caret 5 minus 5x. I always forget to move it down. X caret 5, and then minus 5x. So there's the graph. I'd really rather not trace it. Tracing can be a pain in the butt. I'd rather put the value in. So second, calculate the value, hit enter, -0.5, and that gives me 2.468. So the 2 decimal places, y would be 2.47. Okay, next they want to know, how about when y is equal to -4? Well, it's going to have 2 answers. When y is equal to -4, you can see it intersects it right here and right there. So I'll find those points. Second, calculate, go down to choice 5, the intersection. So I'm going to take the spider over to the first curve, second curve, just hit enter a whole bunch of times. It'll give you the answer. So at y equal to -4, we've got -1.65. Okay, so I'm going to go second calculate the intersection again. Choice 5. So I'm going to take the spider again. I'm going to take them over to here, set them close, and then you hit enter a whole bunch. And it'll tell me the answer. And the intersection is at negative 1.65. Oh, it gave me the same point again. Oh, bad spider. Second calculate intersection. I'm going to hit enter. I think I'll move it this time. Enter, enter. What? Huh. Well, I know it's on the table. If you go to the table, it's at 1, negative 4. So it also intersects it at the number 1, 1, negative 4. What? I think, yeah. All right. So moving on here. On to the back. We want to find intercepts. To find intercepts, that's where x and y are equal to 0. So you want to plug in x equal to 0 and y equal to 0. Well, if x is equal to 0, that would give you 0 plus 0 over 0 squared plus 3 times 0 is 0 over 3 times 0 or 0. So you got 0 over 1, which is 0. So you got the point 0, 0. So that would technically be an x and a y intercept. And then if y is equal to 0, so putting a 0 in for the y, that gives us x squared plus 3x over 3x plus 1 squared. So when x is equal to 0, that's when the top or the numerator is equal to 0. So you don't care about the denominator at all. If the top is 0, like we saw over here, the whole thing is 0. So all you're worried about is the top of the fraction. So when is 0 equal to x squared plus 3x? Well, I'm going to factor out an x, solving this system here. So that gives you x equals 0 for this, or x equals negative 3. So that's another point then. We've got negative 3, 0. So that's an x-intercept. This one's an x-intercept and technically a y-intercept too. All right, on the next one, we want to find points of intersection. Find the points of intersection of the graphs and of the equations. This one's really hard to graph because you've got to solve it for y here and it's squared, so it's going to break it into 2 equations if you try to graph it. I'd rather do substitution. I'm going to solve for the x on this one because it doesn't have the coefficient, so it makes it easier to solve. So move the 2y over, so x equals negative 2y plus 4. So pick that up and plug it in for the x on the first one. So negative 2y plus 4 squared plus y squared equals 16. All right, so now you got to FOIL this. FOILing that out gives you 4y squared minus 16y plus 16. And someone out there is saying, whoa, where'd you get that from? Well, when you FOIL that, that means there's 2 of them. So it's negative 2y plus 4 times negative 2y plus 4. So negative 2y times negative 2y is negative 4y squared. Negative 2y times 4 is negative 8y. 4 times negative 2 is negative 8y. And then 4 times 4 is plus 16. Hence the middle term of negative 16y. So moving everything to one side because it's squared. When you've got a quadratic equation, you want to move everything to one side and make the other side 0. So we got 4 plus 1 is 5y squared on the left. And then we got negative 16y, and moving that 16 over, it becomes negative 16, so that's just gone. So luckily, it's an easy one to factor again. I'm going to take out the y. So y times 5y minus 16 equals 0, so the answers for y are either 0 or 16/5. And I got 16/5 by setting that equal to 0. Move the 16 to the other side, and then divide by the 5, so 16/5. Okay, don't forget now we also need to find the x value because we want to have the whole coordinate point for the whole intersection. So take the 0 for the y and plug it in here. So x plus 2 times 0 equals 4. So that'd make x equal 4. So there's one intersection point, 4, 0. And then let's do it again. Plug in the 16/5 for y. So give us x plus 2 times 16/5 equals 4. So x equals 4 minus 2 times 16/5. And if you work that out on your calculator, it's going to give you, it's going to give you negative 12/5. So you get the point, negative 12/5, comma 16/5. I'll do it on the calculator for you. So we've got 4 minus 2 times 16 divided by 5. So negative 2.4, or hit the math, enter key, and it gives you negative 12/5. Okay, next one. They want us to find the points of intersection using technology, and they solve them both for y, so that makes it really easy. So solving it, since they're both solved for y, just stick it in there. So we've got negative absolute value, that's under the word math, and you go over to ABS, that's absolute value, 2x minus 3, and then plus 6, and the other one is 6 minus x. All right, so this has 2 points of intersection, one here and one there. Let's see if it's nicer to me this time. Second, calculate the intersection. Again, take the spider over near the point, then hit enter a few times, and it'll tell you the point. It's 1, 5. All right, let's do it again. This is where things went bad last time. Second, calculate the intersection. Take the spider over to the other point, hit enter a few times, and we get 3, 3. So there are the 2 points of intersection. All right, so that was kind of your first lesson in calculus for the year. Again, I'm following the Larson book, and this is for a Calc AB class. We're on our way to passing that test, and I plan on all of us getting a perfect score of 5. So join us for the fun.